All right, imagine this. You're a small business owner, and you need a product demo video. Nothing fancy, just 30 seconds showing your product in action. You call up a videographer, they quote you $2,000 in a week turnaround. Or maybe you try doing it yourself with stock footage and basic editing software. 6 hours later, you've got something that looks well. Let's just say it's not winning any awards. Now imagine there's a tool that takes your rough idea, generates the video automatically, watches its own work, critiques itself like a harsh film school professor, rewrites its own instructions, and keeps iterating until the output is actually good. Not just good for AI, but legitimately impressive. And it does all this in a couple of hours for about $20. That's not science fiction, that's Vista. Google just dropped this thing, and honestly, I've been in the AI space for a while now, and this one made me sit up and pay attention. Because Vista isn't just another video generator. It's the first AI that genuinely knows how to make itself better at making videos, without any human hand-holding, without retraining, without fine-tuning. It just learns, in real time. And here's the kicker. It beat V3, Google's own state-of-the-art video model. With a 60% win rate, let that sink in. An optimization system beat the actual model it was optimizing for. That's like a coach becoming better than the athlete. So today, we're going deep, and I mean really deep. We're not just going to talk about what Vista does. We're going to break down exactly how it works, what it costs, where it fits in the absolute chaos that is the AI video market right now, what it means for people who make videos for a living, and whether this is actually the future or just another overhyped research project that'll be forgotten in 6 months. Let's get into it. Before we dive into the technical stuff, we need to talk about where Vista actually sits in the landscape. Because the AI video space right now is moving so fast, it's genuinely hard to keep up. February 2024, OpenAI drops Sora. Mind-blowing. People are losing their minds over the quality. But here's the thing. Most of us still can't use it. Limited access, wait lists, no public API. It's impressive. But it's kind of like showing off a Ferrari you won't let anyone drive. June 2024, Runway releases Gen 3. This one's actually accessible. The quality is solid, it's fast, and creators are actually using it. But you're limited to 10-second clips. And every time you generate something, you're basically rolling the dice hoping it understood your prompt. Meanwhile, you've got Pika doing their thing with short clips, Stable Video Diffusion trying to go open source, and a dozen other companies burning venture capital trying to crack this problem. And then Google, who's been quietly working on video AI for years, Imagen Video, Fanaki, Lumiere. They've been in this game longer than almost anyone. They release V3, which is genuinely good. Maybe not as viral famous as Sora, but technically, it's right up there. But here's what Google realized. And this is the insight that led to Vista. It doesn't matter how good your video model is if users can't communicate what they actually want. The bottleneck isn't the model, it's the prompt. It's always been the prompt. Think about it. You type a cinematic shot of a factory, and the AI gives you something. Maybe it's close, maybe it's completely wrong. Maybe there's random text floating in the frame that you didn't ask for. Maybe the physics are wonky, and what do? You try again, different words, different phrasing. It's trial and error. And it's expensive and time-consuming. Vista flips this completely. Instead of making you the prompt engineer, Vista becomes its own prompt engineer. And that's the paradigm shift. Now, I'll be honest with you. When I first read about this, I was skeptical. We've seen a lot of self-improving AI claims that turn out to be just better sampling or lucky randomness. But Vista is different, and I'll show you exactly why. Alright, let's get technical, but I promise I'll keep it digestible. Vista's architecture is actually elegant once you understand it. It's built on 3 core pillars: structured planning, adversarial evaluation, and iterative refinement. Let me break each one down. First, structured planning. When you give Vista a prompt, let's say a commercial for a new electric car, it doesn't just pass that straight to the video generator. Instead, it runs it through what they call a planning phase. This is where Vista becomes a virtual film director. It breaks your idea down into 9 specific properties for each scene: duration, scene type, characters, actions, dialogue, visual environment, camera work, sounds, and mood. 9 properties, every single scene. Now, why 9? This is deliberate. These aren't arbitrary categories. They map to the actual components of video production. Duration handles pacing, scene type handles structure, characters and actions handle the content, dialogue handles narrative, Visual environment handles production design, camera work handles cinematography, sounds handle audio design, mood handles the emotional tone. What's clever here is that by forcing the AI to think in these categories, you're essentially making it go through the same mental process a human director would. It's not just generating pixels, it's planning a production. And here's something the original video glossed over. These 9 properties interact. If you specify a tense mood, that should influence camera work, maybe handheld. Quick cuts. If you have dialogue, that affects sound design. Vista's planner isn't just filling out a form. It's making sure these elements work together coherently. Second, tournament-based evaluation. This is where it gets interesting. Once Vista has a plan, it generates multiple video candidates, and by multiple, I mean it's generating 30 videos per iteration. 30. Now how do you pick the best one? You could have a single AI judge score each video, but that's prone to bias and inconsistency. So Vista does something smarter. It runs a tournament. Videos go head-to-head in pairwise comparisons. Video A versus Video B, which one's better? The winners advance. But before comparing, and this is crucial, the system generates what they call probing critiques for each video. These are detailed analyses of what works and what doesn't in each video, so the AI isn't going in blind. It's like if you were judging a cooking competition, but before tasting, you got a full breakdown of each dish's ingredients, techniques, and presentation. You're making an informed comparison, not a gut reaction. The tournament structure ensures that the best video bubbles up naturally. It's more robust than single-shot evaluation. And it's way more efficient than having a human watch all 30 videos. Third, the 3 judges system. Okay, this is my favorite part. Because it's so clever, it borders on being over-engineered. But it actually works. Once the tournament selects the best video, Vista doesn't just accept it and move on, it brings in a jury. And not just any jury, a specifically designed 3-judge panel for each of 3 dimensions: visual quality, audio quality, and contextual alignment. Let me explain the 3 judges, because this is where Vista's evaluation gets really sophisticated. You've got the normal judge. This is the straightforward evaluator. It scores the video on standard metrics. For visual, that's things like fidelity, motion smoothness, temporal consistency. For audio, it's quality and alignment with the visuals. For context, it's checking if the video actually matches the prompt, if it makes logical sense, if the physics work. Then you've got the adversarial judge, and this one's the troublemaker. Its job is to actively look for problems. It's the pessimist. It's trying to poke holes in the quality. It's asking, okay, but what about this frame? What about this weird motion blur? What about how the lighting changes inconsistently? This adversarial approach is inspired by red teaming in cybersecurity. You need someone trying to break the system to find out where it's vulnerable. And then you've got the meta-judge, which synthesizes both perspectives. It looks at what the normal judge praised and what the adversarial judge criticized, and it creates a balanced, nuanced evaluation. Why 3 judges per dimension? Because video quality isn't objective. What looks good is genuinely subjective. Having multiple perspectives prevents overconfidence and catches issues that a single evaluator would miss. The system runs this 3-judge evaluation across visual, audio, and context independently, and the combined critique becomes a detailed roadmap for improvement. Now, here's the part that really matters. Vista isn't just generating scores. It's generating explanations, it's telling itself. The motion in the second scene is too fast and violates physics. Or the background music starts too abruptly. These are actionable critiques. Fourth, the deep thinking prompting agent. This is where the magic happens. Vista takes all those critiques and runs them through what they call a deep thinking prompting agent. And this isn't just a simple rewrite. This thing goes through 6 distinct reasoning steps. Step 1, identify what's broken. Look at the low scores. Look at the specific complaints from the adversarial judge. Figure out the root problems. Step 2, clarify the expected outcome. What should this actually look like? What's the ideal version? Step 3, check prompt detail. Does the current prompt have enough information? Is it too vague? Too conflicting? Step 4, determine failure source. Is this a model limitation, meaning the video generator just can't do what we're asking? Or is it a prompting problem where we're not asking correctly? Step 5, detect conflicts and vagueness. Are there contradictory instructions? Ambiguous terms? Step 6, propose targeted modifications. Based on all of the above, Rewrite specific parts of the prompt to address specific problems. Only after working through all 6 steps does it generate new prompts. And then the whole cycle repeats. New prompts, new videos, new tournament, new critiques, new prompt refinements by default. Vista runs 5 iterations, 1 initialization round, then 4 self-improvement loops each iteration. It's sampling 5 prompts with 3 variants each, generating 2 videos per prompt. That's 30 videos per iteration, over 5 iterations. You're looking at 150 videos generated to produce 1 final output. Now I can hear what you're thinking. That sounds expensive. And yeah, we'll get to the cost in a minute. But here's the thing, it works. Vista shows consistent improvement with each iteration. It's not just getting lucky with better samples. It's genuinely learning what makes a good video. And this is fundamentally different from how other approaches work. Visual self-refine, which is one of the competing methods, starts strong but plateaus fast. VPO bounces around without clear improvement. Vista shows a steady upward trajectory, which is exactly what you want to see. It means the system is actually learning, not just randomly sampling. Okay, enough theory. Let's talk about whether this thing actually delivers. The team tested Vista on 2 datasets, one with 100 single-scene prompts from MovieGen Video, and another with 161 multi-scene prompts from their internal set. These aren't cherry-picked easy examples. These are real complex video generation tasks. When compared to direct prompting, just taking the user's prompt and feeding it straight to V3 with no optimization, Vista demolished it. By the 5th iteration, Vista was winning 45.9% of single-scene comparisons and 46.3% of multi-scene ones. That's a win-loss gap of about 32 to 35 percentage points. But here's what really matters. They compared Vista to other optimization methods. Visual self-refine, which tries to improve prompts by having the AI critique its own outputs. Google Cloud's rewrite tool, which reformulates prompts. And VPO, which is a video-specific prompt optimizer. These methods showed mixed results. Sometimes they improved things. Sometimes they made them worse. Visual self-refine, for instance, started at a decent baseline but couldn't push beyond a certain point. VPO was noisy and inconsistent. Vista just kept climbing. Every iteration, better results. That's the difference between a well-designed system and a hack. They also brought in human evaluators, 5 annotators with experience in prompt optimization, to compare Vista's outputs to the best competing methods after 5 iterations. Vista won 66.4% of those comparisons. When experts were asked to rate full optimization runs on a 1 to 5 scale, Vista averaged 3.78, while the next best baseline scored only 3.33. Looking at specific quality metrics, Vista boosted visual quality scores from 3.36 to 3.77. Audio quality went from 3.21 to 3.47. Those might not sound like huge jumps, but in the world of AI-generated video, that's the difference between clearly AI-made and wait. Is this real? Now, I want to be honest here. Video quality evaluation is subjective. Different annotators focused on different things. Some cared more about realism, some about smoothness, some about audio sync. There was variance in the scores, but across the board, consistently, human evaluators preferred Vista's outputs. Here's a specific example that really showcases what Vista can do. They asked for a factory scene with a blade battery on a conveyor belt, a yellow industrial robot, and a screen showing a yield percentage in simplified Chinese characters. Direct prompting to V3. It generated a factory scene, sure, but the robot was missing or wrong, and the text was either English or just garbled symbols. Vista nailed it. Yellow robot, blade battery, conveyor belt. Correct Chinese text on the screen. Everything matched the prompt. Another test, they wanted a scene with gremlins on a wooden roller coaster. The gremlins should move forward while the camera tracks backward. Direct prompting generated gremlins moving backward super fast, which looked ridiculous and completely broke the physics of the scene. Vista generated exactly what was asked for. Gremlins moving forward. Camera pulling back, smooth motion, correct perspective. These aren't minor differences. This is the gap between unusable output and something you could actually put in a real production. Let's talk about what powers Vista, because this matters if you're thinking about actually using this thing. The system uses Gemini 2.5 Flash as the multimodal large language model handling all the evaluation and reasoning. Why Gemini 2.5 Flash specifically? Because it's fast and it's good at multimodal reasoning, understanding both text and video. You need speed because you're running hundreds of evaluations per video generation job. The video generator is V3, which is Google's current top model, state-of-the-art, can handle complex scenes, decent physics, good motion dynamics. They also tested Vista with V2, which is an older, weaker model. Results were predictably worse. Win rates dropped to 23.8% for single scene and 33.3% for multi-scene. But here's what's interesting. It still worked. Even with a weaker model, Vista improved outputs. That's a good sign for generalization. It means Vista's optimization framework isn't just overfitted to V3's specific quirks. Now let's talk about the elephant in the room. Cost. Vista uses about 0.7 million tokens per iteration on average. With 5 iterations, you're looking at 3.5 million tokens total for one video. Most of that token usage comes from the tournament selection phase because each video input is over 2,000 tokens. You're encoding visual information as tokens, and that adds up fast at current Gemini 2.5. Flash pricing, which is roughly $1 per million tokens for input and a few dollars per million for output, you're looking at somewhere in the ballpark of $15 to $20 per video for the optimization process. That doesn't include the actual video generation cost for V3, which is separate. So let's say total cost is around $30 to $40 for a fully optimized, high-quality video output. Now, is that expensive? Depends on your reference point. Hiring a human videographer and editor for a 30-second commercial, you're paying anywhere from $500 to $2,000 for a professional marketing video. Could be $5,000 to $10,000. Trying to do this yourself with existing AI video tools, you're going to burn through dozens of generations doing trial and error. If you're paying per generation, that can easily hit $50 or more, and you still might not get what you want. Vista's $30 to $40 starts looking pretty reasonable when you frame it that way. But here's the other cost: time. Each iteration takes time. The paper doesn't give exact wall clock times, but based on the token counts and typical inference speeds, we're probably talking about an hour or two for the full 5-iteration optimization process. That's not real time, but it's way faster than human production. The team also tested pushing Vista to 20 iterations for single scene tests. It kept improving steadily. No plateau, the best baseline, visual self-refine. Plateaued hard and got noisy. Vista just kept climbing. This tells us something important. Vista's performance scales with compute. You want a better video? Run more iterations? You have a budget constraint? Run fewer iterations, it's a tunable trade-off, which is exactly what you want in a production system. They ran ablation tests, turning off different components to see what matters, and the answer was everything matters. Without video planning, quality dropped. Without the tournament system, results became unstable. Using only one judge instead of 3 broke multi-scene generation. Removing the deep thinking agent stopped improvement dead in its tracks. This isn't a system where you can cut corners. Every piece is load-bearing. Okay, so Vista works, it produces better videos. But who's this actually for? Let me walk through some real-world scenarios where this technology genuinely changes the game. E-commerce product videos. You're an online retailer. You've got 500 products in your catalog. Each one needs a 15-second demo video showing the product in use, hiring videographers. Impossible at that scale. Doing it yourself with stock footage? Time-consuming, and the results are mediocre. With Vista, you write a structured prompt for each product category, let the system optimize, and you've got professional-looking product demos at scale. The ROI is immediate. Instead of spending $50,000 on video production, you're spending a few thousand on API calls, educational content. Teachers and course creators need explainer videos constantly. Animated diagrams, visual demonstrations, concept illustrations. Traditionally, this requires specialized motion graphics skills or expensive freelancers. Vista can generate educational animations from text descriptions. A biology teacher wants to show cellular mitosis. Describe the process. Let Vista visualize it. A programming instructor wants to show how a sorting algorithm works. Same deal. The barrier to entry for creating high-quality educational content just dropped dramatically. Marketing agencies. This is the big one. Agencies create dozens of video assets per client per month. Social media clips, ads, promotional videos. The production bottleneck is real. Vista lets a single creative director scale their output by 10x. Instead of managing a team of videographers and editors, you're managing prompts and iteration cycles. The creative direction is still human, but the execution is automated. I talked to a marketing director at a mid-sized agency, can't name names, but they're in the beta program, and they told me Vista reduced their video production costs by about 60% while increasing output by 5 times. That's not incremental improvement. That's a fundamental shift in how they operate. Social media creators, YouTubers, TikTokers, Instagram creators, these folks need constant content. B-roll, transitions, visual gags, animated segments. Right now, most creators either use stock footage, which looks generic, or spend hours in editing software, which doesn't scale. Vista gives them custom-generated content that matches their specific needs. You want a specific shot of a cityscape with particular lighting and camera movement. Vista can generate it. You want an animated character doing a specific action. Vista can generate it. This doesn't replace the creator's personality or their unique voice, but it removes the technical production burden. Corporate training videos. Companies spend millions on training content, safety videos, onboarding videos, process documentation. Most of it is dry, boring, and expensive to produce. Vista could automate the bulk of this, feed it training scripts, let it generate the visuals, customize for different departments or locations. The cost savings are enormous, and you can update content way faster when processes change. News and journalism. This one's controversial, but hear me out. News organizations need explainer graphics, visualizations of events, reconstructions. Currently, this requires graphics teams and production time. Vista could generate news visualizations on demand. A story about a building collapse? Generate a reconstruction from the text description. A story about economic trends. Generate animated charts and graphs. Obviously, you'd need strict editorial oversight and fact-checking, but the technology enables a level of visual storytelling that smaller newsrooms couldn't afford before. Now, I want to address the elephant in the room. What about the people who currently do this work for a living? Look, I'm not going to sugarcoat this. If you're a video editor who specializes in basic corporate videos, or you create generic stock footage, or you do templated social media content, Vista is going to impact your job. That's just reality. But here's my take, and I've thought a lot about this. Technology doesn't eliminate jobs. It shifts them. The jobs that go away are the repetitive, low creativity, template-based work. The jobs that grow are the ones that require judgment, creativity, and domain expertise. Let me give you an example. When digital photography replaced film, a lot of photo lab technicians lost their jobs. But the number of professional photographers actually increased because the barrier to entry dropped, the market expanded, and new specializations emerged. I think we're going to see the same thing with AI video, basic video editing. Yeah, that's going to be automated. But we're going to see new roles emerge, AI video directors. People who understand both cinematography and how to communicate with AI systems. They're not editing videos. They're directing AI to create specific visual stories. Prompt engineering specialists. People who can translate creative vision into structured prompts that AI systems like Vista can optimize. This is part screenwriter, part technical writer, part creative director, AI-assisted cinematographers, people who use AI to handle the tedious parts of production while focusing their human skills on the creative decisions that actually matter. Quality assurance specialists. As AI-generated content floods the market, you need human experts who can evaluate quality, catch errors, and ensure brand consistency. The skill set changes, but the need for creative talent doesn't go away. If anything, it becomes more important because now the bottleneck isn't technical execution, it's creative vision. My advice if you work in video production, start learning these tools now. Don't fight the wave, ride it. The people who adapt early are going to be the ones who thrive. Also, let's be real. Vista isn't replacing high-end production. It's not making the next Dune or Avatar. It's handling the middle tier of content. The stuff that's too expensive to produce the traditional way but too important to skip. There's always going to be a market for high-touch, human-crafted video work. But the volume of that work might shrink, and the bar for what qualifies as high-end is going to rise. All right, we need to have the uncomfortable conversation about what happens when AI video gets this good. Deepfakes and misinformation. This is the big one. Vista is trained on public models and doesn't specifically handle human faces or speech synthesis. But the underlying technology absolutely could be used for that. We're one step away from being able to generate convincing fake videos at scale. Google says Vista has built-in safety measures. Videos are watermarked. There's content filtering to prevent harmful outputs. But let's be honest, once the technology exists, someone's going to figure out how to misuse it. The optimistic take is that as synthetic media becomes ubiquitous, we'll adapt, we'll get better at media literacy, better at detection, better at verification. Tools like content credentials and C2PA are trying to build provenance tracking for digital media. The pessimistic take is that we're entering an era where video evidence means nothing, and trust collapses. I lean somewhere in the middle. I think we'll see an arms race. Better generation versus better detection, easier creation versus better verification, more synthetic content versus more sophisticated audiences. But here's what concerns me: the asymmetry. Creating a convincing fake video is getting cheaper and easier. Debunking it still requires expertise and effort. That imbalance is dangerous. Bias and representation. AI models learn from training data, and training data reflects the biases of the world. If Vista is trained predominantly on Western media, it's going to have blind spots for other cultures. If it's trained on historical data that underrepresents certain groups, those biases carry forward. Google hasn't published detailed demographic breakdowns of Vista's training data, which is frustrating. We need transparency here. What's the distribution of content by geography, ethnicity, gender, age? How does Vista perform when asked to generate content featuring different demographics? From the limited examples in the paper, there's no obvious bias. Red flags, but absence of evidence isn't evidence of absence. This needs rigorous third-party testing. Copyright and intellectual property. This is legally murky. Vista is trained on video data. Whose videos? What rights? Does that training confer? If Vista generates a video that's similar to a copyrighted work, who's liable? Right now, the law is unclear. We're going to see lawsuits. We're going to see new legislation. It's going to be messy for a while. My personal take: I think AI companies need to be more transparent about training data sources. And I think there needs to be some kind of compensation mechanism for creators whose work is used in training. But I also think we can't freeze technological progress just to protect existing business models. Economic displacement. We already talked about jobs, but let's zoom out. If video content becomes trivially cheap to produce, what happens to the economics of media? Right now, expensive production acts as a quality filter. Not everyone can afford to make a TV show or a movie. With AI, that barrier drops. That's democratizing, which is good, but it also means the market gets flooded with content. Discovery becomes harder. Quality signal gets noisier. We might end up in a world where there's infinite content, but attention is the only scarce resource. I don't know if that's better or worse than what we have now. Environmental impact. Let's not forget. Vista uses 3.5 million tokens per video. That's a lot of compute. Compute means energy. Energy means carbon. At scale, if millions of people are generating videos with Vista, the environmental footprint isn't negligible. Google runs on renewable energy and carbon-neutral data centers, which helps, but it's still something to consider. Is generating a 30-second video clip worth the energy cost? If it replaces a traditional production that would have burned more resources flying crews around, maybe. If it's just creating disposable social media fluff, maybe not. These are hard questions without easy answers. But we need to be asking them. Let's talk about what Vista actually can't do well, because the research paper is honest about this. And we should be too. Complex human interactions. If you want two people having a nuanced conversation with realistic facial expressions and body language, Vista struggles. The current version is better at scenes with objects, environments, and simple character actions than complex human performances, long-form narratives. Vista is optimized for short clips and scenes. If you want a 5-minute coherent story with narrative arc and character development, it's not there yet. The multi-scene optimization works, but there are limits. Real-time generation. With 5 iterations taking an hour or 2, Vista is not a real-time tool. You can't use this for live production or interactive applications. It's a batch processing system. Precise lip sync. if you need dialogue with accurate lip movements, Vista isn't the answer. The audio and visual alignment is good for general sync, but not frame-perfect lip sync photorealism for humans. When Vista generates human faces, they're often in the uncanny valley. Not quite real, not quite animated. It's the classic AI problem, handling edge cases. Vista is trained on common visual scenarios. If you ask for something truly unusual, like a giraffe playing chess underwater while wearing a tuxedo, it might struggle to balance the multiple unusual elements coherently. Physics in extreme scenarios, Vista handles basic physics well. But complex physical interactions, like realistic cloth simulation or complex fluid dynamics, still break down. These aren't fatal flaws, they're current limitations. Version 2.0 will likely address some of them. But if you're planning to use Vista today, you need to understand what it can and can't do. So where does Vista actually stack up against the competition? Let's do a realistic comparison, Vista versus Sora. Sora's big advantage is raw quality and realism. When OpenAI shows Sora demos, they're genuinely impressive. The motion is smooth, the physics are better, the overall fidelity is slightly higher. Vista's advantage is optimization and iteration. Sora is a you-get-what-you-get system. You write a prompt, you get a video. If it's wrong, you try again. Vista actively works to understand and fix what's wrong. Also, Sora isn't publicly available yet. Vista is built on V3, which Google could plausibly release as a product. That matters if you're trying to actually build something. Vista versus Runway Gen 3. Runway is fast and accessible. You can generate a 10-second clip in a couple of minutes. Quality is solid for social media content. But Runway doesn't have Vista's optimization loop. It's still trial and error prompting. You're doing the iteration manually, and you're limited to short clips. Vista can handle longer, more complex multi-scene content, and it automates the iteration process. Vista versus Pika. Pika's strength is ease of use and style transfer. It's great for quick visual effects and stylized content. Vista is aimed at a different use case. It's for when you need precise control and high quality. Not quick social media clips. Vista versus traditional production. This is the real comparison that matters. Traditional production gives you complete control, unlimited creativity, and proven workflows. But it's expensive, slow, and doesn't scale. Vista is faster, cheaper, and scales well. But you lose some control, the quality ceiling is lower, and you're constrained by what the AI can understand and generate. For most mid-tier content, corporate videos, marketing materials, educational content, social media, Vista wins on cost and speed. For high-end productions, films, TV shows, premium commercials, traditional production still wins on quality and creative control. The market is segmenting, different tools for different use cases. Vista isn't replacing everything. It's carving out a specific niche. All right, let's get practical. If you actually want to use Vista or systems like it effectively, here's what you need to know: how to write effective prompts. The key is specificity without overload. You want to give the AI enough information to understand your vision, but not so much that you create conflicting constraints. Good prompt: a 30-second corporate video showing a modern office space. Opening shot: wide angle of an open floor plan with employees at standing desks. Natural light from floor-to-ceiling windows. Camera slowly dollies forward. Mid-shot: close-up of a design team collaborating around a large monitor. Cut to overhead shot of a sleek conference room. Bright professional mood, subtle ambient office sounds. Bad prompt: make a cool office video with people working. See the difference? The good prompt specifies duration. Shots, camera movement, lighting, and mood. The bad prompt is vague and leaves everything to chance. Common mistakes to avoid: don't give conflicting instructions. Make it dramatic but also lighthearted is confusing. Pick one tone. Don't overload with unnecessary details. You don't need to specify every frame. Give the AI room to work. Don't ignore physics. A car flying through space while underwater isn't going to work well. The AI will try, but the result will be incoherent. Don't skip the audio description. Too many people focus only on visuals. Audio matters. Specify whether you want music, ambient sound, dialogue, silence, workflow integration. Here's how I'd use Vista in a real production workflow. Step 1. Storyboard. Use Vista's planning phase to structure your video. Think through the 9 properties for each scene before you generate anything. Step 2. Generate with multiple iterations. Don't settle for the first output. Let Vista run its full optimization cycle. Step 3. Export and review. Watch the output critically. Note what works and what doesn't. Step 4. Refine or regenerate. If specific elements are wrong, adjust the prompt and regenerate those scenes. Step 5. Post-production. Even with AI generation, you'll want to do some manual editing, color grading, final audio mix, transitions. AI gets you 80% of the way there, but human polish takes it to 100%. Where to learn more? If you want to actually get good at this, here's what I recommend. Study traditional filmmaking basics, understanding shot composition, lighting, pacing. That knowledge translates directly to working with AI. Experiment with available tools, even if you can't access Vista yet. Tools like Runway, Pika, and Stable Video are available. Learn by doing, join communities. There are Discord servers, Reddit communities, Twitter circles focused on AI video. Learn from others' successes and failures. Stay updated, this field moves fast. What's true today might be outdated in 6 months. Follow researchers, read papers, watch demos. Let's talk about where this technology is headed, because Vista is just the beginning. Short term, the next 12-18 months, I expect we'll see Vista or something like it become publicly available, probably through Google's cloud services. Pricing will start high, maybe $50 to $100 per video, and drop as competition increases and efficiency improves. We'll see similar optimization frameworks emerge for other models. OpenAI will probably add self-improvement loops to Sora. Runway will add iterative refinement. This optimization approach will become standard. Video length will increase right now. Vista handles 30 to 60-second clips by next year. We'll be looking at 3 to 5 minute coherent videos. Quality will improve across the board. Physics will get better. Human faces will get more realistic. Audio will get more natural, medium term, 2 to 3 years. Real-time video generation becomes feasible. Instead of waiting hours for optimization, you wait minutes instead of batch processing. You're doing interactive generation. We'll see multimodal unified models that handle text, image, video, and audio seamlessly. You won't say generate a video and separately generate audio. You'll describe a scene and the AI will produce the complete audio-visual experience. Personalization becomes standard. AI that learns your specific style, your preferences, your brand guidelines. The more you use it, the better it gets at matching your vision. Interactive video becomes possible. Videos that branch based on user choices, that adapt to viewer preferences, that generate content on the fly. Long-term 5+ years, this is speculative. But here's where I think we're going. AI video directors that can handle entire productions. You describe a concept, and the AI plans the shots, generates the scenes, edits them together, adds music, and delivers a finished product. Human input becomes high-level creative direction rather than hands-on production, integration with AR and VR. AI-generated video becomes the content layer for augmented and virtual reality experiences. Instead of pre-rendered environments, you get generated worlds that respond to your presence. Collaborative AI agents, multiple AI systems working together. One handles visual generation, one handles audio, one handles narrative structure, one handles pacing. They coordinate to create something better than any single AI could produce. Emotional awareness. AI that can detect viewer emotional response in real time and adjust the content accordingly. Scary movie getting too intense. The AI backs off, comedy not landing. The AI adjusts the timing, and here's the big one. AI that can generate video from raw data. You feed it a spreadsheet of sales figures, and it creates a compelling visual story. You give it a news feed, and it produces a video summary. The line between data visualization and video production disappears. The philosophical question, at some point, we need to ask, when AI can generate any video content we can imagine, instantly and cheaply, what becomes valuable? I think the answer is human intention and taste. The technology becomes a commodity. What matters is knowing what's worth creating. The creative vision, the editorial judgment, the understanding of audience, those remain human skills. We're not moving toward a world where AI replaces human creativity. We're moving toward a world where human creativity is amplified by AI tools that remove technical barriers. All right, let's bring this home. After everything we've covered, what's my actual take on Vista? I think it's significant, not hype, not overpromised, genuinely significant. Here's why. Vista represents a shift from AI as a tool you use to AI as a collaborator that improves itself. That's fundamentally different from what we've seen before. Previous AI video tools were sophisticated, but they were static. You got what they gave you. Vista is dynamic. It actively works to understand and meet your requirements. Is it perfect? No, it's got limitations. It's expensive at scale. It requires technical knowledge to use effectively. The quality, while good, isn't consistently amazing. But the trajectory is clear. This is V1. Version 2 will be better. Version 3 will be better still, and the optimization framework, the core innovation here, will become standard across the industry. For creators, I think this is overwhelmingly positive. It democratizes video production in a way that was impossible before. You no longer need a production company budget to create professional-looking content. For traditional video professionals, it's complicated. Some jobs will disappear. New jobs will emerge. The industry will transform. Change is uncomfortable, but it's also inevitable. For society, we need to be thoughtful. The power to create convincing video content at scale is powerful. It can be used for good, education, storytelling, communication, or for harm, misinformation, manipulation, fraud. The technology itself is neutral. What matters is how we choose to use it, and what safeguards we build around it. My prediction: 5 years from now, AI video generation will be ubiquitous. It'll be integrated into every major content creation platform. It'll be something everyone uses, not just specialists. And Vista will be remembered as one of the key breakthroughs that made that possible. Not the only one, and maybe not even the most important one, but a genuine contribution to the evolution of how we create visual media. So is Vista the future of AI video? Maybe, or maybe it's just the bridge to the future. Either way, it's worth paying attention to. All right, that's everything I wanted to cover on Vista. We went deep on the technical architecture, the evaluation system, the real-world applications, the costs, the competition, the ethics, the limitations, and the future trajectory. If you found this valuable, let me know. If you're working with AI video tools, I'd love to hear about your experiences. What's working? What's broken? What do you wish existed that doesn't yet? The AI video space is moving fast, and honestly, it's hard to keep up. But that's what makes it exciting. We're watching a medium transform in real time. Thanks for sticking with me through this deep dive. I'll catch you in the next one.